Hello friends, now we see the topic Organometallic Chemistry. This topic is included in B.Sc third year chemistry syllabus from paper Inorganic Chemistry. Okay, so let us start the topic Organometallic Chemistry. So first we see introductory part. So the term organometallic was first introduced by scientist E.C. Frankland. E.C. Frankland. He was working on organoarsenic compound. Organoarsenic compound, and he was first person to synthesize the dimethyl mercury. So what is mean by organometallic compounds? We see the definition. Organometallic compounds definition. So the compounds which contains at least one metal carbon bond are known as the organometallic compounds. A compound which contains at least one metal carbon bond are known as the organometallic compounds. So the metals are from main group elements or transition elements or from lanthanides, actinides, etc. Lanthanides, actinides, etc. And bonded carbon may be from organic ligands like alkenes, alkynes, aryl, acyl groups, etc. So ये जो ऑर्गेनोमेटेलिक कंपाउंड है इनमें वन मेटल कार्बन बॉन्ड इज मस्ट नीडेड and that metals are generally from the main group elements or transition elements and lanthanides or actinides, and carbon is from alkenes, alkynes, aryl, acyl groups, etc. Okay, understand? We see nomenclature of that organometallic compounds. Here we see some examples. So first example is HgCH3 twice. Hg means which element? That is mercury. CH3 is which group? Methyl group. So name of that organometallic compound is, how many CH3 groups are present here? That is 2. Therefore dimethyl mercury. The next CH3 4, LiCH3 4. So 4 means how many? Tetramethyl, and here which metal is present? Lithium. Therefore tetramethyl lithium. Here which metal? Boron. Therefore trimethyl boron. Here which elements is present? That is sodium and C10H8 group. C10H8, like that. C10H8. means which organic moiety is present, that is naphthalene. And which metal is present? Sodium. So name of that organometallic compound is sodium naphthalide. Sodium naphthalide. Here in this example, C6H5 group is present. How many C6H5 groups are present? That is 2 C6H5 groups are present. And which metal is present? Hg, means mercury. So C6H5 is known as the phenyl group. How many phenyl groups are present? 2. Therefore name of that organometallic compound is diphenyl mercury. Diphenyl mercury. Okay, these are the some examples related to the nomenclature of organometallic compounds. Next point is synthesis and structural study of alkyl and aryl compounds of beryllium. Alkyl and aryl compounds of beryllium. So first we see synthesis, that is preparation. So there are two methods of preparation for that alkyl and aryl compounds of beryllium: transmetallation and metathesis. So first we see first method, that is transmetallation. So transmetallation from mercury alkyl or mercury aryl. Mercury alkyl or mercury aryl. So in this method, alkyl or aryl berylliums are prepared by heating pure beryllium metal with mercury alkyl or aryl group. Okay, so general reaction is when beryllium is reacted with mercury alkyl or mercury aryl, then there is formation of alkyl and or aryl compounds of beryllium plus Hg. So beryllium when heated with mercury alkyl or mercury aryl, then there is formation of alkyl or aryl compounds of beryllium, where here R is the alkyl group or aryl group. Alkyl group or aryl group. This is the general reaction. B, that is beryllium, plus Hgr2, it gives Ber2 plus Hg, that is mercury. So we see one example. First we see preparation of beryllium alkyl group, that is when beryllium is reacted with mercury HgCH3 twice in presence of ether, then there is formation of organometallic compounds of beryllium, that is BeCH3 twice. BeCH3 twice plus mercury. This is the organometallic compound. Which organometallic compound is formed? Dimethyl beryllium. Dimethyl beryllium. This is alkyl compounds of beryllium. Now we see aryl compounds of beryllium. So one example of aryl compounds of beryllium is when beryllium is reacted with Hg C5H5 twice in presence of ether, then there is formation of what? This is, that is BeC5H5 twice plus mercury. And name of that organometallic compound is, here C5H5 is known as the C5H5 is like of that. Okay, this is C5H5, means name of that is cyclopentadiene. So name of that organometallic compound is, how many cyclopentadiene group? 2. Therefore bis cyclopentadienyl beryllium. Bis cyclopentadienyl beryllium, and this is the aryl compound of beryllium. This is alkyl dimethyl beryllium is alkyl compounds of beryllium, and bis cyclopentadienyl beryllium is aryl compounds of beryllium. Now we see second method for preparation of alkyl and aryl derivatives of beryllium. So second method is metathesis. So what happen in metathesis? There is exchange take place between halogen of beryllium halide, and organo group of organometallic compound. For example, which organometallic compound? CH3Li. So organo group which is CH3. Here exchange takes place between that halogen of beryllium halide and organo group of organometallic compounds containing metals like sodium, lithium, etc. So we see example. For example, when beryllium chloride is reacted with methyl lithium in presence of ether, then there is formation of what? Exchange takes place. There is formation of, here 2 molecules required, BeCH3 twice plus twice of LiCl, means which organometallic compound is formed? Dimethyl beryllium. Similar, we synthesize the aryl compounds of the beryllium, that is when beryllium chloride is reacted with phenyl lithium in presence of ether, then there is formation of diphenyl beryllium. BeC6H5 twice, diphenyl beryllium. So this is second method for the preparation of alkyl and aryl derivatives of beryllium. Now we see structure of dimethyl beryllium. Structure. So we know that the formula for dimethyl beryllium is what? Dimethyl beryllium, BeCH3 twice. But this dimethyl beryllium is not monomeric, it is polymeric. So it is represented as BeCH3 twice N. It contains beryllium carbon beryllium bridge in its structure. So how its structure? इसका स्ट्रक्चर कैसे दिखाते हैं? बेरिलियम CH3 beryllium, you can written as it is CH3 beryllium. So this is the polymeric structure for the dimethyl beryllium. Here it contains beryllium carbon beryllium bridge, beryllium carbon beryllium bridge. Okay, so here beryllium and carbon undergoes which hybridization? sp3 hybridization. So how it undergoes sp3 hybridization? You know that beryllium having atomic number how many? 4, having electronic configuration 1s2 2s2. Okay, so in ground state how it is represented its electronic configuration? This is 2s, this is 2p, 1s2 2s2, outermost shell is 2s, therefore 2s2. For carbon having atomic number 6, it is written as having electronic configuration 1s2 2s2 and 2p2. Okay, how it is written? 2s2 and 2p2, 2s2 and 2p2. Okay, then in excited state what happen? This 1 2s electron is excited to 2p orbital, 1 2s electron is excited to 2p orbital, therefore electronic configuration becomes how? 2s1 2p1 for beryllium and 2s1 and 2p3 for carbon, and it undergoes sp3 hybridization. Both beryllium and carbon दोनों भी क्या कौन सा हाइब्रिडाइजेशन दिखाते हैं? sp3 हाइब्रिडाइजेशन दिखाते हैं. So here this sp3 hybrid orbital of each beryllium, sp3 hybrid orbital of each beryllium and bridging carbon combine to form common molecular orbitals and contains 2 electrons. This sp3 hybrid orbital of beryllium and sp3 hybrid orbital of carbon combines to form common molecular orbital and contains how many electrons? 2 electrons, and form the 3-centered 2 electron bond. 3-centered 2 electron bond. So how it is formed? We see here, this is our beryllium, this is another beryllium. Okay, here carbon present, here carbon present. So beryllium CH3, here we written CH3. Okay, CH3. Then what happened? This beryllium having vacant orbital, it is also having vacant orbital. 1 minute. Beryllium, this is another beryllium, this is our carbon. Okay, CH3. Here also vacant orbital, beryllium, this is our carbon, CH3. CH3. Okay, then what happened? Remaining parts B, CH3, CH3, it goes on so on. Okay, so what happened? This carbon containing how many electron? 1 2 3 4. Then this 3 electron, CH3, then here 1 electron and 1 electron from beryllium. Likewise, there it contains how many electrons? 2 electrons. 2 electrons. And center beryllium, carbon, beryllium. Means how many centered? 3 centered. So that bond is known as the 3-centered 2 electron bond. Which bond is formed? in dimethyl beryllium, that is 3-centered 2-electron bond, and that bond is known as the electron deficient bond. Electron deficient bond. This is structure of polymeric dimethyl beryllium. Okay. The extent of polymerization of organoberyllium compound decreases with increase in bulkiness of alkyl or aryl group. We can also draw the structure for di-tertiary butyl beryllium or bicyclopentadienyl beryllium, which are monomeric in nature. Okay. This is synthesis and structural study of alkyl and aryl compounds of aluminium. Last one we see for beryllium, now we see for aluminium. So organometallic compounds of aluminium are known as Ziegler-Natta catalyst. Remember that, Ziegler-Natta catalyst, which are used for the polymerization of alkyl. Ziegler-Natta catalyst. Okay, then we see preparation method. So first method is transmetallation. So in transmetallation process, alkyl or aryl aluminium can be prepared by the action of aluminium on suitable organomercury compound. Action of aluminium on suitable organomercury compound. Okay, so general reaction, when twice of Al is reacted with thrice of HgR2, then there is formation of Al2R6 plus Al2R6 and removal of this mercury. Okay, this is general reaction where R is the what? Alkyl or aryl group. Alkyl or aryl group. Now we see example. For example, first example, when aluminium is reacted with HgCH3 twice, then what form? Which organometallic compound is formed? Al2CH3 plus removal of mercury, thrice of Hg. And name of that organometallic compound is what? Trimethyl Aluminium dimer. Trimethyl Aluminium dimer. So this is alkyl compounds of aluminium. Now we synthesize the aryl compounds. So aryl compounds, how we synthesize? When aluminium is reacted with HgC6H5 twice, then there is formation of Al2C6H56 plus thrice of Hg, and name of that organometallic compound is Triphenyl Aluminium dimer. Okay, Triphenyl Aluminium dimer. This transmetallation process is similar to that for the beryllium. In last point we see that transmetallation process for beryllium. Same thing is for aluminium. Then next preparation method is by using Grignard reagent. You are well known about the Grignard reagent. What is mean by Grignard reagent? How it is formed? What is general formula for the Grignard reagent? Second process using Grignard reagent. So general formula of Grignard reagent is RMgX. RMgX. How it is formed? Grignard reagent, when alkyl halide is reacted with magnesium in presence of ether, then there is formation of RMgX, that is Grignard reagent. So by using of this Grignard reagent, we can prepare the alkyl mixture of RAlC2, R2AlCl and R3AlCl. Okay, so how reaction takes place? RMgCl, Grignard reagent, when reacted with aluminium chloride AlCl3 in presence of magnesium chloride, that is MgCl2, then we get mixture RAlCl2, R2AlCl and R3Al. Here we get the mixture of organometallic compound of aluminium. Okay, where R is alkyl group or aryl group. So mixture of RAlCl2, R2AlCl and R3Al may be prepared by the action of Grignard reagent on AlCl3. This is Grignard reagent on aluminium chloride. This is the second preparation method. And third preparation method is by using aluminium hydride. So alkyl aluminium can be prepared by the action of aluminum hydride on alkene. So for example, action of aluminum hydride AlH3 on alkene. For example, here we taken ethene CH2 double bond CH2. Which alkene we takes place? Ethene. So 3 ethene molecules are required. So there is formation of AlC2H5 thrice. AlC2H5 thrice. Name of that organometallic compound is what? C2H5 group means which group? Ethyl group. How many ethyl group? 3. Therefore, triethyl aluminium. So here we completed the preparation method. First preparation method for alkyl and aryl compound synthesis is transmetallation. Second by using Grignard reagent, and third is by using aluminum hydride. Now we see structure for the alkyl or aryl compounds of aluminium. So general formula for that is Al2R6. So trialkyl as well as triaryl aluminium compound exist in dimeric form containing Al-R-Al bridge and R-Al terminal bonds. So how can we draw first structure for this trialkyl aluminum dimer and triphenyl aluminum dimer? So aluminium CH3 CH3. This is the structure for trialkyl aluminium dimer. And for triphenyl aluminum dimer, how can we write? Aluminium PH aluminium PH. This is for the triphenyl aluminum dimer. So these are the bridge CH3, and that are the terminal CH3, terminal pH. Okay, so this CH3 Al bridge कहा है ना O, Al pH Al और Al CH3 Al, these are the bridge, and terminal bonds which are RAl means PHAl, or here in this CH3Al, 4 terminal bonds are present. So 4 terminal phenyl groups are in one plane. These 4 terminal phenyl groups are in one plane, and which while bridging phenyl groups, that bridging phenyl groups are perpendicular to that plane, to minimize the steric hindrance. In alkyl aluminum compound, the bridging Al-C-Al bonds are stronger. These bonds, Al-C-Al bonds, are stronger than the terminal Al carbon bonds, that is aluminum carbon bonds. Here aluminium and carbon undergoes sp3 hybridization. Aluminium and carbon undergoes which hybridization? sp3. How we know that aluminum having electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p1. Here I write only outermost electronic configuration, that is 3s2, 3p1, and for carbon 1s2, 2s2, 2p2. So in ground state 3s2, 3p1, 3s2, 3p1, and for carbon 2s2, 2p2. In excited state, what happen? 3s electron of aluminium excited to 3p orbital. So 3s1, 3p2, sp3 hybridization. And for carbon, what happen? 2s electron is excited to 2p orbital. So electronic configuration becomes 2s1 and 2p3, and it also undergoes sp3 hybridization. Here also there is formation of 3-centered 2-electron bond aluminium, this CH3, here orbital of aluminium, here carbon, CH3. Here this bond is formed containing 2 electrons. So this bond is known as the 3-centered 2-electron bond. 3-centered 2-electron bond. Thus it contains only 2 electrons. Thus it is also electron deficient molecule. And this is the structure of Al2R6. So in this video we see what is mean by organometallic compounds definition, introductory part, definition, then nomenclature, then synthesis and structural study of alkyl and aryl compounds of beryllium and aluminium. In preparation method of beryllium, there are 2 methods, which are that transmetallation and metathesis for beryllium, and for aluminium transmetallation, and by using second method using Grignard reagent, and third method by using which aluminium hydride. And also we see structure for the beryllium, alkyl and aryl compounds of beryllium. So for this it is polymeric in nature. We in detail see dimethyl beryllium structure. It is polymeric in nature. And aluminium Al2R6, it is dimeric in nature. Remember that. Okay. ये जो है ये ऑर्गेनोमेटेलिक केमिस्ट्री का पार्ट फर्स्ट है. रिमेनिंग पॉइंट्स के लिए आप सेकंड पार्ट भी देखिए. जब आप ये वीडियो देखते हो तब नोटबुक लेकर बैठे और इसके नोट्स भी आप बनाइए ताकि ये आपको स्टडी करने में मदद करे. थैंक यू फॉर वॉचिंग माय वीडियो. लाइक एंड शेयर to your friends. Subscribe my channel. Thank you once again.